All right, here's our next problem on average rate of change of polynomials, and I'm going to do this a little differently than the last video. Same type of problem. We're looking for over which interval does f, the function f, have a positive average rate of change. So function f is a y value, gives a y value, so the y value, f of x, is x squared plus 10. Now, you look at that, notice, whatever input we put in this function, whatever number we put in for x, is getting squared, which means it stays positive. Negative times a negative is positive, positive times positive is positive. So as x increases, or as it decreases, as it goes away from 0, as the value increases, x squared becomes a greater and greater positive number. So whatever we put in here, as long as it's getting further from 0, it's making our y value, f of x, increase. So let's look at it that way. Let's see, this interval goes from x is negative 3 to x is 3. Well, negative 3 squared is the same thing as 3 squared, so my line between those 2 points, negative 3 whatever, and 3, the same y value, is going to be a horizontal line. My y value hasn't changed from x being negative 3 to x being 3. Okay? The function did something in between there, but they're not asking us about what happened in the middle. They're asking us what's the average rate of change. So this one's average rate of change is 0. That's not positive, so we won't select it. Look at the second interval, from negative 1 to positive 2. Okay, if I square 1 and add it to 10, I'll be at 11. If I square 2 and add it to 10, I'll be at something greater. So my point on the left side had a lower y value than my point on the right side, which means I'm going up between those 2 points. That's a positive slope, or a positive average rate of change. So this one is correct. Now, they say I should only choose one answer, so if I did that right, that will be true. Let's confirm that these aren't true, if indeed B is correct. So, going from negative 4 to negative 1, negative 4 is on the left side. I'm going to square that and add it to 10. Squaring 4 is more than squaring 1, so my left point is higher than my right point. So I'm going down, I'm decreasing, so it's not C. And for the same reason, we square negative 3 and it's high up here. We square 1 and it's not as high, and I still have a negative slope. So on that logic, I don't actually have to find the slopes. I just need to know, is it increasing as we go from left to right, or is it decreasing? This is the only one that increases. All right. Here's a problem written in a little bit different format, so let's think about it. It says function g of t equals negative this stuff squared, t minus 1 squared, plus 5. What is the average rate of change of g over this interval? So from t equals negative 4 to t equals 5. Well, they're now asking us for a numeric value of that rate of change. So we're trying to find change in y over change in x. That's our rate of change, or our slope. We need 2 points. One of them is negative 4 something, and one is 5 something. Those are our bounding points. So we're going to put negative 4 into this equation. Negative 4 minus 1 is negative 5. Negative 5 squared is 25. So we have negative, so this negative is that sign. 25 is what we get when we evaluate t minus 1 squared, and then we add 5. So negative 25 plus 5 is negative 20. And then we're going to check what happens when t is 5. When t is 5, 5 minus 1 is 4. 4 squared is 16. But we have this negative out front. So negative 16 plus 5 is negative 11. Now we've got points, the coordinates for these points, so we can figure out our slope. Change in y is negative negative 11 plus 20. Why plus? Because I'm subtracting a negative. Then my x change is 5 minus negative 4. That's plus 4. And I can simplify. So this is negative 11 plus 20 is 9. 5 plus 4 is also 9. So my slope is 1. And we'll enter that right here where they ask for it. Slope is 1. And we're done.